So we're here at MWC 26 with Solace Power. I have Neil and Willem with us today. And it's a really interesting product. Stay tuned with us. We're here to talk about fixed wireless. Neil, to get us off the ground here, what is your product? And just explain a little bit how you as a power company play in FWA.
Sure, well, our product is a technology like this here, hardware based, that lets you deliver power and data between 2 points. And that can be underwater, can be through concrete, or in this case, through glass. And the value to fixed wireless access is that we allow you to install your CPE, which is quite frequently installed indoors, move it outdoors with very low effort.
So that's I think that's the key thing here. Indoor CPE is essentially a most common method really for deployment. You can do outdoor, but it's quite expensive to install. You need professional fitter and so forth. This product, I've understood, you put the 5Gs this side and the rest of it's that side, and there's no cables or anything.
Right, that's exactly true. So the real benefit here is that it facilitates self-install. So you don't have to send that expensive truck roll. So your OpEx can be the same as it would be for installing it indoors. But yet you get all that performance gain of an outdoor installation. So everybody wins. Consumer wins with better bandwidth, and telco wins with a much lower deployment cost.
Yeah. Willem, tell us a bit about the penalty for indoor deployment versus outdoors.
If you look to fixed wireless access, first of all, end users, they consume a ton of data, much more than on mobile networks, because it's a family service that you get with large screens in the house, etc. So you get a lot of data. Number two, with 5G, in most cases, the mid bands are being used. These are bands 2.5 to 4 gigahertz, and they have a significant attenuation when going from the outside to the inside, in the range of 10x to even 1000x, 10 dB to 30 dB loss when you get into the house. The point about that is that you need much more network resources to transfer the same data when you're in the inside versus while you're on the outside, which translates into more capacity on the network and more capacity for the end users. So basically, indoor deployments has been the norm so far. 80% or more of deployments are indoor, but as operators start to run out of spectrum, there is a massive benefit of moving the CPE outdoor, which was
yeah, it's a big. I think like a low E window could be like 30 dB of attenuation.
Oh, yeah.
So we're talking massive capacity wastage almost by always running indoors. What does that do then, Neil, for the operator? How, that seems kind of obvious, it's going to help a lot, but just frame that a little bit for us.
Well, there's two things happen. One is the actual potential number of customers more than doubles right away. So no change to infrastructure, just move it outside, and all of a sudden you get the service more than double the number of customers you already have. The other thing that happens that maybe is a little deeper to think about is when you do your planning, you're trying to say, well, how many customers are in this area? I'm going to spend this amount of money to stand up a tower, install all this equipment. And you can very much predict, if everything is outside, what the coverage is going to be. Well, if it's inside, that's not so easy, because you don't know the wall thicknesses, the wall materials can all vary, the window types and the coatings can all vary. And the placement inside the home, which can be moved around by the consumer, is infinitely variable. Yeah. So what from a planning perspective seems like a simple, straightforward, well understood engineering problem is absolutely impossible to get an accurate assessment of when it's indoors. You move it outside, not true. It's going to be pretty much as designed.
Yeah, so we're talking pretty huge gains. Tell us then, there are obviously outdoor CPE already. It's not a new invention per se to put it outdoors, but why this is better than using a cable? It's kind of like, I'm asking a question, it seems obvious, doesn't it? But just elaborate a little on how that helps. I suppose first of all, really the end customer.
Well, a cable, cable is always going to be more efficient and less costly, but a cable will need to be put on a window that opens. That's the first problem. Not all windows open. Yeah. Only a few in your home. And it needs to be facing a tower where you have coverage. second problem is the cables must be really thin, and even then, when you close a window on them, well, actually, some windows don't even allow you to close it, put a cable, but those that do. So again, now we're in an even smaller percentage. That cable is going to leave a small gap, even if it's smaller. Well, in colder climates, that's a problem. Even in the hot climates, it's a problem because cold is coming in or it's going out, right? And also, if you make them too thin, those cables, and even if they're not, they will break over time.
Yeah, I'm with you. I mean, I think you can get people who claim there's no impact on your installation or your cooling, but like I don't really want that in my house. I'm with you on that. I think
sit next to your window.
Okay.
Tell me.
So where are we in terms of creating FWA products with this through glass technology?
So we've taken the module and it's here. We've taken it through ourselves certifications, make sure that there is no question. And we've produced quite a number of them for trials. We've also now are in with our partner Netcom into some of their CPE, and we are also in others, Pure Wi-Fi product as well, and we're talking to other vendors.
Okay, good. Pretty heavy hint here that we're on a FWA booth, so you can kind of figure out we're getting there. So essentially it's at this point, I don't know if we can pan in, but it's essentially a prototype.
Proof of concept.
Proof of concept, essentially. But looks really good, works really well. What I wanted to do though, Neil, was take you back then to the other industries that you're working in with this wireless power technology and help us understand how some of the learnings there, some of the progress there, we can actually apply into the telecom industry.
Okay, so we do work in two other verticals mainly. One is aerospace defense and the other one is automotive. So both of those environments demand solutions, and if this is true for physical connectors, that can survive our harsh environments, and not only harsh but changeable environments. So when we started to develop this technology from the beginning, we had this mission where we wanted to make it as practical as possible to deploy, to actually replace in the cases where that physical connector is creating a problem, replace it with this wireless connection. So for us, our technology we developed to be able to transfer power under the sea. So we can actually put this underwater and transfer power between 2 points. And in order to solve that problem, we had to develop a lot of software and very sophisticated hardware techniques that allow us to adapt to the environment. And that served us very well in this case. The windows are highly variable. They can be single, double, triple panes. They can have low E coatings or not, and the low E coatings can be on different panes and multiple panes and different locations. So it represents a high degree of variability. Our challenge was to do it with one SKU. No one wants to be able to carry a truck full of options around, and that's what we've done. So one thing we've learned in automotive, and I'll say particularly, is that there's a no-nonsense approach. They want something that works really well and something that doesn't create more problems than it solves.
Willem, just bring me in. We're talking there about the different windows. Just tell us how the window type, the makeup of it, impacts your strategy here, because obviously there's an infinite variety of windows, I guess.
Yeah, well, first of all, that's very true. Across the world, you see many types of windows, and the main variables are the thickness, overall thickness of the window, the number of window panes, as Neil was saying, but also very important, the metal coating. So even those, they do have metal coatings, which can be hard coated, soft coated, 1 layer of silver, 2 layer, 3 layer of silver, etc. So for the viability of such a product, it's extremely important that you can cover a wide range of windows. No operator will deploy any fixed wireless access if only 20-30% of the windows could be coped with. So the technology, when you start it up, it will basically analyze the window, check what the width is, check the number of metal coatings, and then it will adapt itself such that it transfers exactly the right amount of power which is needed to be received by the modem.
And so you say you can't do this with 20, 30% window coverage. Where do you think you are with your, you do your analysis?
Yeah,
Have you got 70% coverage?
More than that. We did, for instance, for the US market, roughly about 97% of the US market is either single pane or dual pane with 1, 2, or 3 layers of silver, and we can deal with all of that. So roughly we can cope with 97, 80% of the windows in the US and similar in Europe.
With essentially one SKU of the product.
Exactly.
So that's a pretty large addressable market. I guess then when we put ourselves in the place of the operator, the ISP, Willem, that's going to have that amount of addressable market with the gains you get being on the other side of the glass. What does that translate to in terms of, I guess, network capacity and business impact?
Yeah, so for instance, in the past, we did some analysis on a live network of an operator, and looking at the numbers, we saw that if 16% of the bad indoor CPE, which has a hard time to grab the signal, if we move that to the outside, that we gain 60% in network capacity.
Wow.
So not 10 or 15%, but 60%. And if you have
just by moving what?
By
10% of the users?
16% of the users or 17% of the users from the inside to the outside. So, and if you have an idea of what a mobile network costs, what the radio and the RAN costs and so on, this is a lot of money. That's one thing. Has two impacts for the operator. First impact is that if you go outside, the cost per user significantly goes down, or the network cost per user significantly goes down, which gives you a better return for that customer. But secondly, and which is becoming very important at this moment, is that a lot of operators, with the success of fixed wireless access, they start to run out of spectrum. Mm-hmm. Not everywhere at the same time, but definitely there are hotspots where there is no room left. With this technology, making it self-installable, they can expand to a lot more customers than they could do today. So in the net, it's, let's say, 5-6 years ago, operators could deploy 5G fixed wireless access without any restrictions. There's plenty of spectrum available. That has changed over the last.
Yeah, they're kind of hitting a little bit the limits now, aren't they?
Absolutely.
If they want to protect their mobility users as well. So
yeah, absolutely. So they're basically coming at the end, and such technology basically allowed them to continue deploying fixed wireless access for many years to come.
Okay, sounds terrific. Neil, I'm going to close with you. If you had to leave the fabulous audience of ISPs and mobile operators with a simple message about this wireless power product, what would it be?
Well, the idea that you have to compromise between speed of deployment and performance, network performance, is no longer true. That's a legacy problem, and it's now solved by technology, and you can have your cake and eat it too.
Sounds like the kind of cake I like.
Yeah.
Neil, thanks a lot.
Thank you.
And Willem, thank you.
Gabriel,
Cheers.
All right, thank you.